Okay, so with Unit 10 and 11, I dealt a lot with quadratics. So you need to know that in vertex form, a quadratic formula looks like y equals a in front to the x minus h squared plus k. And the reason why they call it the vertex form is because the vertex is the opposite of h, that's what the negative sign's for, and the same sign as k. So the opposite of positive 2 is negative 2, the same as negative 3 is negative 3. This a value in front determines how skinny it is and whether or not it is a positive or a negative quadratic function. So since it's positive, that means it's going to open up. Okay. Domain is all real numbers, and the range is all real numbers. Since this is a function that's opening up, we're going to do greater than or equal to whatever the y value is, negative 3. Okay. So let's take some time to graph it. And while we graph it, we're going to make a table, a t-chart, x comma y. And we're going to put the vertex right in the middle, negative 2 comma negative 3. So two numbers that are less than negative 2 are negative 3 and negative 4. Greater than negative 2 is negative 1 and 0. And we just plug each of these numbers into the function x plus 2 squared minus 3. So when you plug negative 4 into this function, that's negative 4 plus 2 squared minus 3. And that comes out to positive 1. You plug negative 3 into this function. And then again, do please excuse my dear Aunt Sally. That comes out to negative 2. And since it's symmetric about the vertex, that's also negative 2 comma 1. You could plug it back in to check to see if it does come out like this. I promise you it does. So at negative 4 comma 1, there's a point. At negative 3, negative 2, there's a point. Negative 2, negative 3, there's a point. Negative 1, negative 2 point. And 0 comma 1 point. And just connect them all as best you can. I'm drawing with the mouse, so I have an excuse. Okay, the line of symmetry is the same as the x value of the vertex. That means if you were to put a line straight down the middle, it's symmetric on both sides. So that's your line of symmetry, x equals negative 2. The vertex is a minimum because it is underneath everything. If it was on top of everything, it'd be a max. So on the same graph, we're going to graph this function. So we're going to need a new t-chart. So you have x comma y. Okay. And we need to plot our vertex first. Our vertex is at positive 4, positive 2. So two numbers that are less than 4 are 2 and 3. Greater than 4 are 5 and 6. And we need to plug them all into the function negative 2 times x minus 4 plus 2. So when you plug 6 in, negative 2 parentheses 6 minus 4 squared plus 2. That's 2. 2 squared is 4. Negative 8 plus 2, negative 6. When you plug in a 5, that's going to be 0. And it's symmetric about the vertex, so those are the same. Okay, so let's plot it on the same graph. So we have 4 comma 2. 1, 2, 3, 4 comma 2. we have 3 comma 0 and 5 comma 0 and 2 comma negative 1, 2, 3, 4, 5, 6, and same thing on the other side. Alright, connect them all to make your graph. I gotta go say hi to my dog. Okay, sorry. He deserves loves. So, the vertex here is opposite of what's inside, so the opposite of negative 4 is positive 4. And the same as the outside, so positive 2. The max of g of x is equal to 2, because that is the biggest one. Domain is all real numbers, and the range is all real numbers. And since this front number over here, the negative 2, is negative, that means it's going to be less than or equal to 2. Notice how all of the values of this function are below. That's why it's less than or equal to. The line of symmetry is going to be x equals 4. Again, the line of symmetry is the x value of our vertex. So, like that. And is 6 comma negative 6 a solution? So let's check. If we go right 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, that point is on our graph, which means yes, it is a solution. You can also check our t-chart to know that it is also a solution. Okay. Name 2 other solutions to f of x. 3 comma 0 is a solution, and 5 comma 0. If it is on the line, it is a solution. Okay. The descriptive form of a parabola, blah, 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 is best to reveal the minimum or the maximum without changing the equation. All right. So let's scroll on down to the next part. So for the next part, complete the chart and the graph. So we're going to plug x into all these and see what's going on. So when you plug x into here, actually, I'm going to factor it first. If I factor this first, then the front two need to multiply to be x squared, so that's x and x. Back two need to multiply to be -8, but add to -2. So I'm thinking -4, +2. Okay. So that means if I plug 4 into this function, 4 squared minus 2 times 4 minus 8, we get 0. Okay. And if I plug -2 into this function, I also get 0. Okay. So I know the vertex is somewhere in the middle there. So let's go with 4, 0, 2, 3, 4 is one of our points. And -2, 0 is a point. Okay. So let's plug in the rest of this stuff. We got 3 squared minus 2 times 3 minus 8. So that'd be -5. Plug in 2 squared minus 2 times 2 minus 8. That's -8. Plug in 1 squared minus 2 times 1 minus 8. That's -9. And then 0 squared minus 2 times 0 minus 8. That's -8. You'll see that some of the answers start repeating themselves, and that's because 1, -9 is the vertex. So the line of symmetry is x equals 1. That means -5 is this answer. And we could keep it going. If we plug in -3 squared minus 2 times -3 minus 8. That's 9 plus 6 is 15, 7. And I believe the next one's going to be a 16. So let's plot all the points. We've got -1, -1, 2, 3, 4, 5, 6, 7, 8. Oh, whoops, that's wrong. That should be -1, -5. And 0, -6, 7, 8. And 1, -9. And 2, -8. 3, -5. And then we got 4, 0. Then we got -3, 1, 2, 3, 4, 5, 6, 7. And it's going to go off our grid. So it looks a little like this. Explain how to get the line of symmetry. It's the x value of the vertex. The x-intercepts are 4, 0 and -2, 0 as evidenced by these 2 points, because you got 0 when you plug those in. The y-intercept is 0, -8. That is the value when you plug 0 in for x. And when you factor it, which I already did up there, we get x minus 4, x plus 2. What is between the factors and the x-intercepts? They reveal the x-intercepts. Okay. Look, the opposite of -4 is +4. The opposite of +2 is -2. Plots them right away. Okay. And it says the standard form of this blah 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 is best to reveal the value of the y-intercepts without changing the form. The reason why you know it's the y-intercept is because you can just look at this number and that's your y-intercept. Okay, it says the y-intercept is 0, -8. -8 is just the thing at the end, because when you cross out all the x's, That's the only thing that's left. So that's nice and fast. The factored form is best to reveal the intercepts. Or another thing you can say instead of the intercepts are the zeros of the function. Okay, next problem we're going to do is problem number 3. Okay, we're going to sketch x squared. So x squared starts at 0, 0, goes to 1, 1, 2, 3, wait, 2, 4. Okay, and the reason why I know it goes there is because I can make a little t-chart. XY t-chart and do -1, 2, -1, 0, 1, and 2. And when I plug it in, I get +4, +1, 0, 1, 4. Okay, so this one right here is x squared. So to sketch the translation, this says go right 3, down 2. So we go right 1, 2, 3, down 1, 2. Right 1, 2, 3, down 2. And you just take basically every point and go right 3, down 2. Okay. And here's the new one. Okay. What is the equation of t of x in descriptive form? That would be y equals x minus 3 squared minus 2. Because our function shifted to a vertex of +3, -2. Okay, so increasing or decreasing. So r of x was the first one, so that is this guy. And decreasing. Decreasing is when it's going down. So notice it's decreasing all the way here until we get to the vertex. So it's decreasing when x is less than 0. And it's increasing when x is greater than 0. Because when it's greater than 0, it's going back up. Like that. Less than, greater than. Okay, next part. Find the average rate of change. I say rate of change, you say slope. Yes, very good, class. Slope is the average rate of change. So let's find the average rate of change. Okay, so you need to know the slope formula. Okay, the slope formula is y2 minus y1 over x2 minus x1. Okay, so this number right here, that's x1 because that's the first x. That's x2 because that's the second x. We need to plug it into that function. So y1 is equal to 2 squared, which is 4. y2 is equal to 5 squared, which is 25. So you plug it into the rate of change, you have 25 minus 4, all over 5 minus 2. And that's 21 divided by 3 for an answer of 7. Okay, when you do the same thing for this one, we have 5 squared is 25. 8 squared is 64. So the rate of change is 64 minus 25, all over 8 minus 5. And that gives us 39 divided by 3, which is 13. So the average rate of change is different. What does that mean about the graph? It means it's not linear. So to solve the following equations, a couple ways we can do this. We can factor, we can do PEMDAS backwards, or we could do a quadratic formula. So let's do PEMDAS backwards. The first thing we're going to do is add 18 to both sides. So we get 2x squared is equal to 18. Then we divide both sides by 2, and that gives us x squared is equal to 9. Then we square root both sides, and we get x is equal to positive 3 and negative 3. Remember, you always get two answers when you take the square root. Okay. So next problem, we are going to again subtract 48 from both sides. So this becomes 75x squared is equal to negative 48. Then you divide both sides by 75. And we get x squared is equal to, let's also reduce this fraction while we're at it. They're both divisible by 3. 48 divided by 3 is negative 16. 75 divided by 3 is 25. And then we're going to square root both sides. The square root of negative 16, actually we can't take the square root of a negative, so that means we're going to have an I in front. We're going to have a positive I, or actually let's take the square root of this. Square root of 16 is 4, square root of 25 is 5. But since you can't take the square root of a negative, you're going to have an I. So your answer is positive 4/5 I and negative 4/5 I. Okay. For this, we need to factor. I'm going to factor. This would be an x, and the back they need to multiply to negative 21, but combine to make negative 4. So that's going to be a negative 7 and a positive 3. And then I just take the opposite of each of these numbers. My answers are positive 7 and negative 3. Okay. For this one, I'm going to factor out a 2 in front first. And I'm left with x squared plus 9x plus 20. And then when I factor, I get x in front for each of them. And then in the back, they need to multiply to 20, but add to 9. So that would be 5 and 4. So that means my answers are negative 5 and negative 4, because they're just opposites of whatever's in here. Next problem. Okay. For this guy, this one's going to be a little bit harder. So let's start off with guess and check. Front 2 need to multiply to be 2x squared, so that's 2x and x. We need to multiply to be 18. So let's think of all the numbers that multiply to be 18. We have 1 and 18. We have 2 and 9. We have 3 and 6. So it's some kind of combination of those guys. Okay. I know that I cannot use 18, I cannot use 2, and I cannot use 6 on the left side because they have that 2 in common. Remember, we don't want to have a common factor. So I know I either have to put a 9 in there. I know I have to put like a 3 in there maybe. Let's try 3. Okay. Actually, let's try 2 and 9 first. We'll do 9 and we'll do 2. 9 times x is 9x. 2 times 2 is 4. And notice how those two do not combine to make negative 15 at all, in any way possible, shape, or form, even if they were both negative. So that means can't do 9 and 2. So I should have stuck with my original guess. Let's go with 3 and 6. 3 times x is 3x. 2x times 6 is 12x. And if you make them both negative, that means that this becomes negative 15x. Sweet. So they're both negative. So to solve this, I need to set each of them equal to 0. I have 2x minus 3 equals 0, and I have x minus 6 equals 0. This is what you're really supposed to do for the previous problems, but I just got lazy and took the shortcut. So for this one, we add 3 to both sides. So 2x equals 3. And then divide both sides by 2. We get x is equal to 3/2. And then for this one, we just add 6 to both sides. And we get x is equal to 6. Okay. For this one, it needs to be equal to 0 before you start. So we need to move this 10 over. So our new problem is now 3x squared plus 17x plus 10 equals 0. Alright, so let's factor it if we can. Front needs to multiply to be 3x squared, so that's 3x and x. Backs need to multiply to be 10 and combine to 17, so 5 and 2. Remember, if you factor and you check and it doesn't work out, you should probably switch some stuff around. There's 2x, there's 15x. They both combine to make 17x, so we're all good and happy. So that's correctly factored. So that means we're going to do a 3x plus 2 is equal to 0. And an x plus 5 equals 0. When you solve each of these, you're going to get x equals negative 2/3 and negative 5. Okay. You can try this one, but just know that when you do the guess and check, that's 2x, and that's x, and 1 and 1. There's no other combination that you can possibly do to get to 5x. It's pretty much impossible. So we need to do the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that means this is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 1 all over 2 times 2. So this is negative 5 plus or minus the square root of 25 minus 8, which is 17, all over 4. And that is going to be our final answer for part G. For part H, I'm assuming we're going to have to do quadratic formula again, so I'm just going to go right into it. I'm not even going to try to factor it. You might be able to factor it. You might not be. I'm not going to risk it. So x equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 4 all over 2 times 3. And notice you can use quadratic formula for any of the previous problems. Yeah, quadratic formula will always work. So this is negative 2 plus or minus the square root of, I think that's 52 all over 6. However, 52 can be simplified. I'm going to pull it over here. We can use the little factor tree. 52 is 2 times 26. 26 is 2 times 13. We have a pair of 2's. So this is actually negative 2 plus or minus 2 root 13 all over 6. And notice that this number, and the denominator are all divisible by 2. So if we reduce this, this is actually negative 1 plus or minus the square root of 13 all over 3. And that's as far as it goes. Okay, we're going to do next. Number 6. Simplify them as possible. So we're going to do it just like we normally do. Square root of negative 72 is actually, if you break it all up, the square root of 36 times the square root of negative 1 times the square root of 2. The square root of 36 is 6. The square root of negative 1 is I. And that's just the square root of 2. That's as simple as it could be. Square root of 96. Okay, so I was able to just do this without doing the factor tree because I knew that 36 was a perfect square number. Sometimes you won't always be that lucky, so let's do it like this and see how we do. So that's a 4 and a 24 that I'm going to use. And 24 is going to be a 4 times 6. That's 2 and 2, 2 and 2, 6 is 2 and 3. So I have 2 pairs of 2's. So this is going to be a 2 times 2 in front, because there's 2 pairs. I, because there's a negative under the root. And since 2 and 3 are left over, we multiply them back and get 6. So this becomes 4I root 6. Okay. For C, we're going to double distribute just like we've normally been doing. 4 times 1 is 4. 4 times 2i is going to be 8i. 3i times 1 is 3i. 3i times 2i, that is a 6i squared. So we have 4, 8i plus 3i, that's 11i. However, you need to know that I squared is negative 1. So this now becomes a negative 6. Whenever you have an I squared, it changes the sign in front. So this final answer is negative 2 plus 11i. Okay. And for this one, we double distribute. 7 times negative 4 is negative 28. 7 times 9i is going to be a 63i. Negative 3i times negative 4 is going to be a positive 12i. Negative 3i times 9i will be a negative 27i squared. And remember, the I squared changes the sign. So this is negative 28 plus 63i plus 17i plus 27. So negative 28 plus 27 is negative 1. 63 plus 12, I don't know why I put 7, is a 75i. Awesome. Okay, next part. Oh, thank goodness, this part's almost done. Okay, find the correct numbers. So if you want to solve this, okay, we have to complete the square. To complete the square, you use negative b divided by 2 squared. So negative 4 divided by 2 squared is equal to negative 2 squared. which is equal to 4. Okay, so I always write it out like this. Done? Awesome. So this is going to be an x squared minus 4x plus blank, whoops, plus blank minus 6 equals 0. So 4 is what I need to put into each of the blank spaces. This first part right here is going to factor, and if you take a look at this number in the parentheses right here, this -2, that guy, that is actually what it factors into. So it's an x minus 2 squared, and -4 minus 6 is -10, equals 0. So if we add 10 to both sides, we get our answer. This is an x minus 2 equals positive 10. Okay, it says then solve it. So from here we're going to square root both sides, and we get x minus 2 is equal to either the positive or the negative square root of 10. Then we're going to add 2 to both sides to get a final answer of 2 plus or minus the square root of 10. Okay. Next thing, I'm going to set up an x squared minus 16x plus blank minus blank equals 0. And we're going to do a negative 16 over 2 squared, which is a negative 8 squared, which is 64. So 64 here, 64 here. So this first part is going to, oh, I forgot the minus 17, whoops. So that part is going to factor into an x minus 8 squared. And negative 64 minus 17 becomes negative 81. So that's going to be an 8, and that's going to be a positive 81 when I add 81 to both sides. To solve it, we square root both sides. So we get x minus 8 equals positive 9, and x minus 8 equals negative 9. When we add 8 to both sides, we get two answers. We get x is equal to positive 17, or x is equal to negative 1. For part C, they want us just to put in the quadratic formula, so start plugging stuff in. Minus 4 times a times c all over 2 times a. So this becomes positive 5 plus or minus the square root of 25. Negative 4 times 3 times negative 1 is plus 12 all over 6. So this all becomes 5 plus or minus the square root of 37 all divided by 6. Okay. Next part, part D. Part D, same thing. So it's a negative 2 plus or minus the square root of 2 squared minus 4 times a times c, all divided by 2 times 2. So this is negative 2 plus or minus the square root of 2 squared is 4, minus 4 times 2 times 5, that's going to be 40, all over 2 times 2, which is 4. So this is negative 2 plus or minus the square root of negative 36 all over 4. Since there's a negative, that means it's going to have an I in it. So this is negative 2 plus or minus 6i, because the square root of 36 is 6, all divided by 4. Notice how every number here is divisible by 2. We can reduce this. So this is negative 1 plus or minus 3i all over 2. Next problem. Okay. So it might help if we sketch the functions. So start off with the vertex. That's -4, +2. 2, 3, 4, +2. And it's negative, which means it's going to go downwards. So I'm just sketching this. I should probably do a table of values with it. Kind of don't want to, though, and I'm sorry. So it looks something like this. And then the other function says 0, 5, 2, 3, 4, 5. 1, 0, 2, -1, 2, 3, 3, -4, 4, -3, 5, 0, 6, 1, 2, 3, 4, 5. Alright, there's our other one. Okay. So this one was k of x, and this one that we did second was m of x. So this says the maximum value of k of x, maximum value of k of x, that's the biggest number, that's 2, is greater than the minimum value of m of x, which was -4. That is a true statement. The value of x when k of x is at its maximum. So k of x is at its maximum here, and that value of x is -4. It says is greater than the value of x when m of x is at its minimum. And that number right there is a +3, because it's 3, -4. And that is false. Both intercepts of m of x are greater than 0. So here's one intercept. Here's the other intercept. So 1 and 5 are both greater than 0. The intercepts are 1, 0, and 5, 0. The line of symmetry for k of x is x equals 4. That is false, because the line of symmetry is at the x value of the vertex, which is over here, and that is at x equals -4. Okay, and the y-intercept of m of x. So the y-intercept is the y value when x is 0. So of m of x, that is going to be this value up there, 1, 2, 3, 4, 5, is greater than, I don't know what the number is going to be, but it's somewhere over there, so I know it's going to be true. Okay, that's going to do it for 10 and 11, and then I will finish the last ones another time. Good luck.